Okay, so today we are going to be finding how long it takes a jalopy to accelerate to the speed of light with this acceleration. And we are also going to be finding how much distance the jalopy is going to cover as it's accelerating to the speed of light with this acceleration. Now, so we're going to use first this kinematics formula. This kinematics formula here to find the time. Using the final velocity is going to be the speed of light. The initial velocity is going to be 0. The acceleration is going to be 0.041 meters per second, and the time is the unknown variable. So, when we divide both sides by 0.041, we will find the time is equal to that many seconds, which, when we convert into years, is 231.5451681 years. So, effectively, if you're trying to accelerate a jalopy to the speed of light, considering that there is no friction or air resistance, and that the jalopy is structurally stable enough to be accelerated to that speed, it will take you 231 and approximately a half years. So don't do it. Now, we're going to find how much distance this is going to cover. So, we're going to use this kinematics formula. Because we know time, acceleration, initial position, initial velocity. So the only unknown variable is the final position. So we know that we will have our final position is 0 plus 0 plus 1/2 of 0.041 times t squared. I'm just going to use t squared because that is extraordinarily long. Now when we actually solve this out, the final position is equal to 1.096042901 times 10 to the 18th meters. So that is a very long distance, and we really can't compare anything to that. So I'm going to change it into light years. And the way we're going to do that is that light travels 9.46 times 10 to the 15th meters in a year, and that's why it's a light year. It's just that distance. It's that 9.460730473 times 10 to the 15th meters. So when we convert this into light years, we get that it's actually 115.851826 light years. So that is how many light years it would take. But that's really not, again, we can't really think about that. So we'll see how much time this jalopy would have to lap the Earth. So I'll just keep this number here, which is the final position, and is showing how far the jalopy has to travel in order to accelerate to the speed of light. So we know that the radius of the Earth is going to be 6,378,100 meters. Now, to find we'll treat the Earth as being circular for the purposes of lapping it. So the radius is here. So 2 pi r is going to be the circumference. So 2 times pi times the radius is going to be that is the circumference of the Earth in meters. Now, what we're going to do to find how many times it would have to lap the Earth is we're going to divide this number, the distance that to travel, over the distance of the circumference of the Earth. So, from that, we find out that the jalopy would have to lap the Earth Okay, so the jalopy is effectively lapping the Earth approximately 27 billion times. So, in other words, you're not going to be able to do this, so don't try to accelerate a jalopy up to the speed of light anytime, if it has an acceleration of 0.041 meters per second. Thank you.